and all of my sessions are recorded, and you get a copy of that just as soon as I can process it. I should have it by this evening later, but normally I guarantee you that I have it by the next morning. Sometimes, like if I have 5 sessions, it takes a whole evening to process the files so that you can hear them. All right, so you know what chapter you're on in your book?
Yeah, we're doing chapter 1.1 through 1.3 right now.
Okay, so a preview of calculus, which means you're doing limits.
Yeah, limits.
Okay, do you have some problems that you want to go over?
Yeah, I think 1.3 is what I mostly need to go over.
I'm sorry, I didn't hear that last part. What was that?
1.3 is what I mostly need to go over.
Okay, let me turn to 1.3. So
yeah, mostly
1.3 is pretty much limits of polynomials. So do you have some problems you want to give me and we can go over those? If not, I can give you some. But limits are a new branch of math for you, for everybody that encounters calculus for the very first time.
yeah.
You don't get limits anywhere else. For example, what's the limit of x minus 3 over x squared as x goes to 4?
1 over, so 1.
1 over what?
1.
Actually, as x goes to 4, it would be 1 over 16.
Yeah.
Okay. Now, any limit that goes to a number over another number is easy. In other words, when you have direct substitution like this, then it's particularly easy. If I said to you, what's the limit of x over 3 as x goes to 0, what would that limit be?
0.
Okay. If I said, what's the limit of 3 over x as x goes to 0? Have you had one-sided limits yet or just two-sided?
A little bit of both. Are those ones the ones that are D and E?
No, well, no. Actually, the D and E would be if x goes to 0. But if x goes to 0 from the plus side only, this limit is infinity.
Oh.
And I know they like to use the word D and E because most math teachers don't like to use the word infinity. But
Yeah.
the fact is that if the limit of 3 over x as x goes to 0 from the left side, well, that's negative infinity. And one rule about limits is if the limit from the left side does not equal the limit from the right side, then the limit does not exist. In other words, if I say, well, what's the limit of 3 over x as x goes to 0, that does not exist. But the only reason it does not exist is because the limit's different from the left side than it is the right side. First of all, do you see why the limit from the right side is positive infinity?
Yeah.
And the left side is negative infinity.
Mm-hmm.
If those two numbers are different, then the limit does not exist regardless of anything else. Okay?
That makes sense.
All right. So what kind of problems are, well, let me give you another one. So numbers over numbers, 0 over a number, and a number over 0, those are all, you can figure those out. The ones that are difficult are the ones that are 0 over 0. For
Right.
example, this one. And at some point in time, you get nothing but this. Okay? In other words, they don't give you any of the easy ones anymore. So if I were to do direct substitution here, I would have 0 over 0. Well, that's called indeterminate. And what indeterminate means is that it could be anything. It could be anything from negative infinity to positive infinity. It could be 0, it could be 4, it could be 3.5. Okay? So 0 over 0 after direct substitution are the difficult limit problems. And that's all of the ones you're going to see on the test are
Right.
difficult ones. Okay? Well, the first thing you want to consider is factoring. Okay? If you factor the top, what's x squared minus 1 factored equal to?
X squared plus 1 and x squared minus 1?
Well, x minus 1 and x plus 1.
Oh, yeah, that's right.
Okay? And now if I divide that by x minus 1, the x minus 1's cancel, and I'm left with x plus 1. Well, now what's the limit of that as x goes to 1?
2.
Yeah. In other words, my 0 over 0, which I started out with, actually becomes 2 when I do some algebraic manipulation of it. And that's pretty much going to be what you're dealing with for most of this chapter, is factoring. And which means that when you first substitute, you get 0 over 0, but by the time you factor and cancel, it turns into a number.
Okay.
Okay? So, do you have any specifically? I could give you more, but I would just be giving you examples out of the book, which you have already. So it's better if we do the one, well, here's a, well, let me stick with that. Do you have any?
Can we do number 53?
On what page?
On page 68.
So my 53 is square root of x plus 5 minus square root of 5 all over x?
Yeah.
Okay. Yes, we can do that. So I'm taking the limit of square root of x plus 5 minus square root of 5 all over x as x goes to 0. And of course, that's by direct substitution, you end up with 0 over 0. Okay? Well, when you see an expression like this, I can't factor it, but when you see radical signs, think multiply by the conjugate. In other words, I can take any fraction and multiply it by 1, correct?
Mm-hmm.
Well, here's my 1. That expression is 1. And what I'm going to do is multiply top and bottom by that and see what happens. In other words, this is just the second method of solving when you have 0 over 0. Factoring was one method. The second method is multiplying by the conjugate. Now, the reason you multiply by the conjugate is because notice what the top becomes. What's this top by that top equal to?
Just x plus 5 plus 5.
Exactly. Actually, it's x plus 5 minus 5.
Oh.
In other words, if I do the multiplication, top only, I get the square root of x plus 5 times square root of x plus 5. That gives me x plus 5. The two middle terms cancel one another. And that's the reason we multiply by the conjugate, is because we know the next two terms are going to cancel one another out, but then the final term is that. Okay, so the top goes to just x, and the bottom goes, you don't want to usually multiply these out, you want to leave them just like this. Can you see that okay?
Yeah.
We're taking the limit of that I just circled as x goes to 0. Well, notice the first thing that happens is the x's cancel. So now I'm left with 1 over that. Well, what does that go to as x goes to 0?
1 over root 5 plus root 5.
Yeah, 1 over 2 root 5. Root 5 plus root 5 is 2 root 5. And that's a number. So the moment you get it to where you do not any longer have 0 over 0, you've got the answer. And look to use this technique whenever you see radical signs of complicated expressions like we're looking at here. Square root of x plus 5 minus square root of 5. That's a complicated thing. I can't do much with that. I can't really factor it. I can't do anything with it. But I can multiply it by the conjugate. And multiplying by the conjugate is really valuable when you have this, because it gives you an answer that completely eliminates the radical signs from the numerator. And by reducing the numerator to x, we can cancel it out with the x in the denominator, and now we have 1 over some number. All right. Do you have like the odds? What's the next one you have?
Oh, I don't have any like specific homework problems or anything. Just kind of.
Oh, you were just kind of looking at them and figuring out what to do?
Yeah.
Okay. Let's look at 59.
Okay.
Here we have, and make sure this is the same 59 as you have. And now we're beginning to get into something that looks a lot like the definition of first derivative. Okay. And notice that direct substitution gives you what?
0 over 0.
Right. So distribute first. Distribute this 2, you get 2x plus 2 delta x minus 2x all over delta x. Now what does that go to?
2 delta x over delta x.
Yeah, that cancels. In other words, there's no x left. And the delta x's cancel, so that actually goes to 2. As delta x goes to 0. The key in all of these limit problems is going to be to find some factor in the numerator that cancels with this thing in the denominator. And after you cancel it, well, you're left with a 1 down there and a 1 up here. And so when I say cancel, I don't really mean it goes to 0. I mean it goes to 1. And now you don't have 0 over 0 anymore. You have 2 over 1. And that's the way all of these limit problems are solved, is whether you have to factor to get it to a different number and cancel, or whether you have to use the conjugate, which is what we used previously. In other words, on this problem here, I got, by multiplying top and bottom by the conjugate, I was able to then factor an x from the top and the bottom, leaving me no longer with 0 over 0. And that's the secret to all of these limit problems. Now, let's see, we have another 10 minutes. There's a third technique. Let's talk about it. Let's look at number 67. There are basically 3 techniques for doing these limit problems. One is factoring and canceling. The other is multiplying top and bottom by the conjugate. We've done one of each of those. And this is a third situation. Now, the one thing they teach you, because calculus is kind of funny in that you have to know this to make much progress. So they tell you to memorize this. Do you know what that limit is?
1?
Yes. And it's not clear because the sign of x, the sign of 0 is 0 divided by 0. So again, you get 0 over 0. But this ends up being 1. If I were to graph sine x over x, this is what you would see. Notice that as we approach 0, we approach 1. Okay? And it's not clear at all that that's what you would get from looking at it, because it's 0 over 0, so you don't really know how to handle it. So this one, they tell you, memorize this until you learn more calculus, and then we'll tell you how we got it.
Oh.
And that truly is what they expect you to do. In other words, they've kind of got a problem where they got the chicken and the egg. They don't know which comes first. They can't really teach you the calculus involved in solving this. There's something called L'Hopital's rule. Are you familiar with that?
No.
Well, let me give it to you because it may save you a test question. If I have a limit of something that goes to 0 over 0, I can take the derivative of the top and the derivative of the bottom, resubstitute, and I'm going to get my answer. Well, you don't know it yet because you haven't learned derivatives, but the derivative of sine is cosine, and the derivative of x is 1. Now, if I substitute 0 for x here, I get cosine of 0, which is 1 over 1. So that gives me the limit using this thing called L'Hopital's rule. Now, you don't get L'Hopital's rule until chapter 8 of this book.
Okay.
And you're not even going to get that this year. It's going to be next year. But L'Hopital's rule covers anything that's 0 over 0 or infinity over infinity, things that are indeterminate. Well, L'Hopital came along and said, well, if you can take the derivative of the top and the derivative of the bottom and reevaluate, then you get the answer. But until then, they just want you to memorize this. that is 1. Okay? So now if we look, let's look at a slightly easier one. What if I had sine of 3x over x as x goes to 0? Well, notice we still have 0 over 0, right?
Mm-hmm.
But if I multiply the top and the bottom by 3, now I know what that goes to. What's that go to?
1
times 3, so that limit is 3. Okay? Now, if I look at problem 67, it's similar to that. It's sine of x over 5x. So I have to multiply top and bottom by what so that they match? Not 5. If I multiply top and bottom by 5, I would have 25x on the bottom. About 1/5.
Oh, yeah.
And then that gives me 1/5 sine of x all divided by x. And we know that goes to 1, so this whole thing goes to 1/5. Okay? And that's pretty much the third method of doing limits, and I don't know of any others. I only know of 3 methods. And between these 3 methods, you can solve all limit problems. There's one other limit that they ask you to memorize without telling you why. And I think it's this one. Let's see. No, that would be 0 over 1. Excuse me, it's this. In other words, if you do direct substitution here, you get 0 over 0, right?
Uh-huh.
But this limit is 0, not 1. Different than the sine x over x. Sine x over x is 1. This is 0. And these are the 2 that they ask you to memorize so that they can give you the rest of these limit functions that have trig functions in them. First of all, let me ask you, are they giving you problems after number 67?
Yes.
Okay.
Or no. I think our last one was 68.
68? Let's look at 68.
Okay.
In the last 4 minutes here, we can do 68. So I'm taking the limit of 3 times 1 minus cosine x, and tell me if this differs in your book. We might have the same book, but sometimes they change the exercises at the back. Well, direct substitution gives you 0 over 0, but I can separate this. In other words, I can separate this into 3 times 1 minus cosine x over x. Right? Those are the same expressions. What's that go to?
0.
So 3 times 0, that whole thing goes to 0. And that's basically how you're going to do all of these trig functions that you see in exercises 67 and beyond. Is you're going to use one of these 2 that they asked you to memorize. In other words, the 2 are sine x over x. The limit of that as x goes to 0 is 1. Memorize that. And memorize this. 1 minus cosine x over x as x goes to 0. That whole thing goes to 0. And between those two, you should be able to solve every one of the exercises from 67 on.
Gotcha.
Okay. Tangent, just remember your trig identities. Your trig identities are huge, incidentally, in calculus. It's amazing how many calculus problems you need to use your trig identities. You need to know that tangent is sine over cosine. Or you need to know that 1 minus cosine squared x is sine squared x. Those kind of identities. It truly is amazing how big a part of calculus trig is. So you want to be strong on your trig equations or your trig identities.
Okay.
Okay. Brianna, I got to go. I have a 4:30 session. Hopefully this gives you a pretty good idea how my online sessions work.
Yeah, awesome.
And this is recorded. I'll stop